Precalc 1.4. We're going to talk about fractional expressions. What is a fractional expression, aka rational expression, possibly? There's slightly different definitions for those. Does anybody have a definition for the fractional expression? No? Maybe? Give it a shot. Dead space on the... Fractional means...
Fractions.
Okay.
A fraction or a quotient of two algebraic expressions.
Yeah, it's just two algebraic expressions with a fraction or a quotient. So quotient of algebraic expressions. I know I shouldn't put expressions in there because it's an expression. The difference between a fractional expression then and a rational expression, they are technically the same thing. It's just that they use polynomials. They use polynomials in the rational expression. So this book uses the fractional expression a lot. I'm still going to say rational expression because all the books that lead up to this pretty much use that. So just a big fraction of algebra. And so I got a couple steps there. And these steps actually cover the first couple examples. And it's to simplify. Because anytime we have a fraction, you always want to simplify it to the best of our ability. So number one, you just factor each numerator and denominator completely. You're going to want to break it down to all of its parts. And if we're multiplying or dividing, use the appropriate rules. So I put that in there after because some of our problems are not just being simplifying fractions. We're going to take two fractions and multiply them and divide them. Remember, when you multiply fractions, you can multiply across. And when you divide by a fraction, you flip and multiply. So you can't forget those. Then, two, what we want to do is start to cancel out common terms that appear on the top and bottom. Remember, this only works when we are multiplying and dividing our terms. If there's addition and subtraction going on between terms, it's out. You can't divide, unless you can divide something completely out front, you can't cancel them. So, are you ready for some examples? The first example is x squared minus 1 divided by x squared plus x minus 2. Our goal is to simplify this. Rookie mistake. Rookie mistake. Algebra 2 first day. Yes, I just heard it. They want to do this. Oh, look at that. It's just negative 1 on top over x minus 2. No! Don't do that, please. That's a rookie mistake. Again, I just said if they're added or subtracted, you can't do that. The only way or time you can do this is if they are multiplied. So, let's take that out of there. Can I factor the top? X squared minus 1. I hope everyone says yes. That's the difference of squares. What do you get then? X plus 1, x minus 1, or x minus 1, x plus 1. It doesn't matter. The bottom, the numerator, or denominator, sorry. X squared plus x minus 2. A is equal to 1. These are the nice ones, yeah? Yeah. So it's x. Factors of 2. Oh, there's only one pair. So it's 2 and 1. I have to get a positive in the middle. Plus 2 minus 1. And we recognize what? Yes, Max? The x minus 1's cancel, leaving us with x plus 1 over over x plus 2, and you are done. We're happy as a lark. We've done that before many, many times. Bird. I think so, right? It's a bird's a lark, lark's bird. Happy as a clam. Don't know where these things come from. They look like they're smiling, I don't know. The next one is x squared plus 2x minus 3 divided by x squared plus 8x plus 16 times 3x plus 12 all over x minus 1. These guys follow the number 1 rule, part A, where it says follow your exponent rules after you factor everything. So, the way I like to do this is say, hey, I think I'm going to be able to factor that first fraction like so. The second fraction is not a trinomial. It's not squared. So I'm possibly going to factor something out of there, right? And that last bottom term doesn't look like I'm going to do anything. I just kind of mentally set it up. So I set this up for myself. So then I can go self x squared plus 2x minus 3. Ooh, a is 1. I like that. That's x. Factors of 3. 3 and 1. It's going to throw 3 and 1 in there. And it has to multiply to a negative but add to a positive. So it's plus 3 minus 1. Moving to the bottom. A is still 1. These are nice. Is it always going to stay that way? Probably not. Bless you. As we start getting into there, it's going to probably get a little bit crazier. Make sure you factor by grouping then. 16, that'll give me an 8. 4 and 4, or plus plus. Can I cancel anything on this one? Not yet. Okay. Next, what can I take out of there? Take a 3 out. And I get x is 4. So I've factored everything. Now I'm just going to apply my fraction rules. I am multiplying. If I multiply fractions, what do I do again? Just multiply across. Now, here's something really cool that I like to do. I think this is super cool. Is because they're just multiplied, and everything's multiplied, what if I just extend the fraction bar straight across? Now it just acts like a big fraction, just like the first problem we did, and now I just go hunting for like terms to cancel out. Yes? So, what's the first thing I want to cancel?
X plus 4.
Ooh, some x plus 4. So these ones are gone, right? Okay. Oh. Don't do that.
Only one of them in the top.
One top, one bottom. Okay. Just one on the top, one on the bottom, and x minus 1s. So then when I go to rewrite this, make sure you kind of write it more common sense way. The 3 in the back. Constants always go in the front. So 3 times x plus 3 over leave it like this. Don't FOIL or distribute the 3 in. The reason is you want someone else to be able to come into the room and say, yep, that's fully reduced. Right? And the last one I think we'll do today on the bottom there is x squared minus 3x minus 4 divided by x squared plus 5x plus 6 times x minus 4 divided by x squared minus 4. So I think, again, 3 out of the 4 of them will be factored. Excuse me. And x minus 4 will go along for the ride. What's the first top one going to be? Factors of 4, that give you 3.
1.
4 and 1. Minus 4 plus 1. Moving to the bottom. Factors of 6, they give you a 5. 3 and 2. Wait a minute, can't a 1 and a 6 also give you a 5? Yeah, 6 is positive, so that means that they both have to be positive or both be negative. Therefore, you could not get to a 5. So, 2 and 3, and both signs are positive. And the last one is the difference of squares. Minus 2 and plus 2. They're multiplied. I'm going to put a parentheses around the x minus 4 on top there that I didn't have, just to make sure that I can see that it is a factor. And I'm also going to bridge the gap. Can we cancel anything? No. I realized that it did not come through correctly, but make this a division sign. It won't affect anybody up to this point. We thought we were just going to multiply across. But now, okay, we factored it. It was supposed to be division. It didn't come through on the paper. I must have hit the wrong button. I wonder why I wasn't canceling. But guys, if it didn't cancel, then means you would have an x minus 4 squared, right? Because you have an x minus 4 times x minus 4. It's fine. Sometimes you can simplify, or that is completely simplified. So, say we are dividing, which means that the front half will stay exactly the same. X plus 2 and x plus 3. But then I'd multiply it by x minus 2, x plus 2, all over x minus 4. I'm thinking everybody's seeing where this is going. What cancels? X minus 4's and an x plus 2. And you're left with x plus 1, x minus 2, all over x minus 3. Your homework, guys, for 1.4 is page 42, 1 through 13 odds. Have a fantastic day.